The Boötes Void, sometimes called the Great Nothing, is one of the largest known voids in the observable universe. It is an immense region of space that contains far fewer galaxies than expected, making it appear almost empty compared to surrounding cosmic structures. Discovered in 1981 by astronomer Robert Kirshner and his colleagues during a redshift survey, the Boötes Void revealed that the universe is not uniformly filled with galaxies. Instead, matter is distributed in a vast cosmic web of clusters, filaments, and enormous empty regions. The Boötes Void lies in the direction of the constellation Boötes and has a diameter of roughly 250 million light-years. To grasp this scale, consider that the Milky Way galaxy is about 100,000 light-years across. The void is therefore thousands of times larger than a single galaxy. Even galaxy clusters, which contain hundreds or thousands of galaxies bound together by gravity, are tiny compared to this immense region. If one were to travel across the Boötes Void, one would traverse hundreds of millions of light-years with very few galaxies encountered along the way. Despite its name, the Boötes Void is not completely empty. A small number of galaxies exist within it, but their density is dramatically lower than the cosmic average. Observations indicate that instead of the hundreds or thousands of galaxies that might be expected in such a volume, only a few dozen are present. These galaxies often appear isolated and are not part of large clusters. Their existence shows that even in the most underdense regions, gravity still allows some structure to form. The discovery of the Boötes Void was significant because it supported emerging evidence that the universe has a large-scale structure resembling a web. Galaxy redshift surveys measure how much the light from galaxies has been stretched by cosmic expansion. By mapping redshifts across the sky, astronomers create three-dimensional maps of galaxy positions. These maps reveal that galaxies are not randomly scattered. Instead, they form sheets and filaments that surround vast voids. The Boötes Void is one of the most dramatic examples of such an underdense region. The formation of cosmic voids is closely linked to the evolution of the early universe. After the Big Bang, tiny density fluctuations were present in the hot plasma that filled space. Over billions of years, gravity amplified these fluctuations. Regions that were slightly denser than average attracted more matter and grew into clusters and filaments. Meanwhile, regions that were slightly less dense lost matter to their surroundings, becoming emptier over time. As matter flowed outward, the underdense regions expanded faster than average, eventually becoming large voids. Dark matter plays a crucial role in this process. Although invisible, dark matter constitutes most of the universe's matter content and shapes gravitational dynamics. Computer simulations that include dark matter successfully reproduce a cosmic web structure with clusters, filaments, and voids. The Boötes Void fits naturally into this framework. It represents an extreme case of underdensity formed through gravitational evolution over billions of years. One question that initially puzzled astronomers was whether such a large void could form within the standard cosmological model. Early theoretical work suggested that voids of this size might be rare. However, as galaxy surveys expanded and computational models improved, scientists found that large voids are expected, though uncommon. The Boötes Void is large but not inconsistent with current cosmological theory. Voids provide valuable information about cosmology. Because they are underdense, they are sensitive to the properties of dark energy, the mysterious force driving the accelerated expansion of the universe. As space expands, voids grow larger and emptier. Measuring how voids evolve over time helps scientists test models of cosmic expansion and gravity. In this sense, the Boötes Void is not merely an absence of matter, but an important laboratory for studying the universe's fundamental components. Another interesting aspect of the Boötes Void is its psychological impact. Human intuition expects space to be filled with galaxies wherever we look. The realization that enormous regions exist with almost nothing inside challenges that intuition. The cosmic web suggests that most of the universe's volume is actually contained within voids, not within galaxies or clusters. In terms of volume, emptiness dominates structure. Despite its dramatic nickname, the Great Nothing is not a tear or hole in spacetime. It does not represent a region devoid of physical laws or gravitational influence. Instead, it is simply an area where matter density is far below average. The few galaxies present continue to orbit under gravity, and dark matter still permeates the region, albeit sparsely. In conclusion, the Boötes Void is one of the largest known cosmic voids, spanning about 250 million light-years. Discovered through redshift surveys, it helped reveal the universe's large-scale structure as a web of filaments and empty regions. Formed through gravitational evolution and shaped by dark matter, The void exemplifies how slight early density differences can grow into enormous cosmic features. Though often described as the Great Nothing, it is not truly empty, but rather a vast underdense region that deepens our understanding of cosmic structure, expansion, and the dominance of emptiness in the universe's overall architecture. If you like the video, share it and don't forget to subscribe. Cosmic Secrets 108, turn on notifications. See you in the next video.